Hi, my name is Angela Dapremont, and I am a PhD candidate at the Georgia Institute of Technology, where I study mud volcanoes on Mars. Here's an example of a positive relief landform previously suggested to be the result of the geologic phenomenon of mud volcanism. This particular surface feature is located in the Mars Canyon system Valles Marineris. And so here you can see its circular morphology and unique textural characteristics. So I first wanted to provide a brief description of what mud volcanism is, which can be described as a process whereby fluid-rich fine-grained sediments ascend within a lithologic succession because of their buoyancy. So mud volcanoes are the surface expression of this process occurring on Earth in both onshore and offshore environments. And so when it comes to applying this terminology to Mars, some caution has been suggested by previous researchers, primarily due to possible behavioral differences associated with this geologic process among Earth and Mars. For example, on Earth, for a feature to be accurately described as a mud volcano, rigorous criteria must be met. Also, lab experiment results suggest that putative Martian mud volcanoes may differ in shape compared to those on Earth. So subsurface sediment mobilization is an alternative term that can be considered appropriate for Mars, and it encompasses mud volcanism. On Mars, proposed mud volcanism sites are not exclusive to any particular region, which is what this map shows here. This is a colorized global elevation map with black squares denoting all suggested mud volcanism sites on the Martian surface by previous researchers. And these features have been proposed to occur, as we can see, in the northern lowlands, equatorial regions, and southern highlands. Morphological descriptions of proposed mud volcanoes on Mars have varied and include pitted cones, some examples of which are in an area we have studied, which we termed the Hephaestus Phosphate region. So you can see in these high-resolution images that these features have bright crater rims, some of which are well-defined, some of which show likely geologic degradation, as well as their smooth flanks. And so when it comes to the study of Mars mud volcanism, visible and near-infrared spectroscopy has only been used in a few locations. And so more could be done to incorporate these data sets to assess the validity of the mud volcanism hypothesis for these landforms and improve understanding of the expected compositional characteristics, formation history, and associated environmental conditions under which this process operated on Mars. So we conducted a global study of the compositional characteristics of proposed mud volcanoes on Mars using visible and near-infrared spectroscopy. So we used data from the Compact Reconnaissance Imaging Spectrometer for Mars, specifically targeted data at 18 or 36 meters per pixel, as well as the spectral ratio method. And so today, in the context of VNIR spectroscopy, I'm going to discuss the three sites that you see over top the map, designated by the white stars, because these are the locations of some of our most significant findings. So in Valles Marineris, these features have been morphologically described as knobs and rounded knobs, and these are outlined by the white boxes. And our VNIR spectroscopy analysis showed the presence of 1.4 and 1.9 micron water overtone absorptions, consistent with the presence of hydrated minerals associated with these features. These water overtone absorptions characterize the green, purple, red, teal, and orange spectra seen on the center plot. And the presence of unaltered hydrated glass is also suggested based on a 2.23 micron absorption associated with the purple spectrum in the center plot, along with those 1.4 and 1.9 micron water overtone absorptions. Also, the 1.4, 1.9, and 2.23 micron absorption positions are marked by black dashed lines. So clastic pipes, which are injectite features, or they have been defined rather as injectite features interpreted to have developed through liquefaction and fluidization, have been grouped with mud volcanism features on Mars. And so we can see some examples of these in these high resolution images. The VNIR spectroscopy analysis shows the presence of 1.9 micron water overtone absorptions, which is also designated by the black dashed line in the center plot. And so a final set of features described as knobs in Valles Marineris interestingly showed the presence of high calcium pyroxene, and this alludes to an igneous origin rather than a mud volcanism origin for these features. And so in Arabia Terra, there are these mounds that have been proposed to be the result of mud volcanism. And here, the VNIR data show 1.9, 2.1, and 2.4 micron absorption, suggesting the presence of a monohydrated, polyhydrated sulfate mixture. Now, we interpret this potential sulfate identification with caution because some of the spectral features that we see are not dissimilar in magnitude to artifacts attributed to noise. However, we do note that additional mounds in the region exhibit those previously mentioned 1.4 and 1.9 micron water overtone absorptions, indicating the presence of hydrated minerals. And in the spectral plot here, the dashed lines are positioned at 2.1 and 2.4 microns. Finally, in Terra Serenum, a mound exhibits a 1.9 micron water overtone absorption, and this absorption is consistent, again indicating the presence of hydrated minerals associated with a proposed mud volcano in this particular region. And so these results allow us to take a global look and come up with some major conclusions about the compositional characteristics of proposed mud volcanoes on Mars. For example, that these landforms exhibit variable degrees of hydration. So this is revealing useful information about the differences in water content associated with this process across the Martian surface. Our study also provides useful insights for comparative planetology purposes. And so while Perseverance is not landing at a mud volcanism site, our work certainly provides a possible guide for future robotic and or human exploration of Mars. And so thank you so much for taking the time to listen today. I hope you gathered some useful information about mud volcanism on Mars. Thank you.